Okay, this is for numbers 29 through 32 on the worksheet, and this is the shadow problem. A street light 13 feet above the sidewalk, or a street light is 13 feet above the sidewalk. This is right over here. A boy 4.5 or 4.5 feet tall walks away from the light at a rate of 4 feet per second. Determine the rate at which the boy's shadow is lengthening. That's how fast the tip of the shadow is moving. At the moment, he is 11 feet from the base of the light. So I'll do a sketch over here. And here's my street light. It's about 13 feet tall. Here's my boy who's about 4.5 feet. Now he's walking away. And we want to find out how, this is the length of his shadow right here. And we want to find out how fast that is lengthening or growing. That means the tip of the shadow is moving this way as the boy walks this way. The shadow is moving this length is moving as he walks over. This is lengthening. You can kind of think about it like if, here's what's happening. So as the boy is moving forward, you can see that the shadow is lengthening over here. It's going like this way. So that means the tip of the shadow is moving. So they want to find out again, how fast is the tip of the shadow moving, or the rate at which the boy's shadow is lengthening. So we want to find dsdt. So that's what we're looking for. So if we read what we've got, he's walking away at a rate of 4 feet. So this rate here is 4 feet because he's walking away from the lamppost. So that would be dx dt. So dx dt equals 4 feet per second. Okay. All right. And when he's 11 feet from the base of the shadow, so when x equals 11, we want to find out ds dt. Now, we're going to use similar triangles. We know that this is a right triangle, and if the boy's standing straight up, that's going to be a right triangle, and they both share this angle. So by angle, these two triangles are similar. So we know the ratio of the corresponding sides is the same. So we can set up our mathematical model of the situation by using similar triangles. And we know that 13 big triangle to small triangle over 4.5 equals big triangle, which is this whole length, which is x plus s, all over the small triangle, which is s. So big triangle to big triangle, big triangle to big triangle to small triangle, big triangle to small triangle. So 13 is to 4.5 as x plus s is to s. So be careful, that's this whole thing. Now we have a decimal mixed up with a fraction. We don't like that. So the easiest way to deal with this is to multiply the top and the bottom by 10. So we'd have 130 over 45. And that equals my x plus s all over s. And then I can simplify this. I think 5 goes into both those. So 5 goes into 130 twice 10. 26 times. So I've got 26 over, and 5 goes into 45 9 times, and that's what we got. So that equals x plus s all over s. Okay, so we simplify that a little bit. Then we can just cross multiply, because we got some s's we can simplify. So we've got 26s equals 9x plus 9s, and then if I subtract 9s from both sides, 26 minus 9 is 17, so I have 17s equals 9x. And then I could solve for s because I want to find ds dt, so I could divide both sides by 17. So I have s equals 9 over 17 times x, and then I can just take the derivative with respect to t of both sides. ds dt equals 9 over 17 times dx dt. And we're looking for this. We've got the dx dt is 4. So we have 9 over 17 times 4. That's going to be feet per second. That's going to be my ds dt. And 9 times 4 is 36, and there's no simplifying, so that's what we got. So DSDT equals 36 over 17 feet per second. And it's relatively easy, and as it works out, it doesn't matter what the x is. So it's just not a problem. It kind of falls out here when we take the derivative. So again, just make sure you know how to deal with it. As if you happen to have a decimal 4.5 feet. I think I might have used 5.5 feet, 4.5 feet in some of the problems. So that's the easiest way to deal with it and simplify it. Okay, change that decimal. When you have a fraction decimal, just change it just to multiply the top and bottom by 10 or some power of 10, and that'll get rid of the decimal. Okay.